Okay. Good morning, students. So, are you able to hear me?
Yes, ma'am.
Yes, ma'am. Good morning.
Good morning. So, we'll start. Uh, okay, before starting, I wanted to ask you whether everybody is having Proteus installed on your laptop.
No, ma'am.
No. Have you used before this Proteus?
No, ma'am. No, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So, mixed reaction. Okay, if I have to share something with you, is there any email ID or everything will be shared on the WhatsApp? Mm. Hello?
There
Hello?
is no common email ID for the subject as of yet.
Okay. So that means I need to share on WhatsApp only because I'll share you the Proteus folder to install because hardware implementation is not possible. So whatever is possible in Proteus simulation, that will take, and for that you need to install that Proteus. So I'll share you the Google Drive link on the WhatsApp. You try to install that Proteus. Okay.
Okay.
And books also through Google Drive. I'll share everything on the WhatsApp. I'll share you the link so that you can get
Can
all
you
the
share it
material.
on the Teams?
Teams. Yeah,
Because
if
other
possible.
subjects and notes and everything is on there as well.
Okay.
So,
Okay, I'll try to. I'll also put everything on the Teams also.
okay.
So for those who are not able to access Team 8, so they can refer from the Google Drive link. Okay.
Okay.
Okay. So yesterday we have covered the components of four-stroke engine and working of the engine has been explained through the video. And I think Anmol has explained us how the initial cranking takes place or initial movement of this piston will take place. Okay. So is there any doubt in that? So we'll just revise the this engine working. What are the strokes or what do you mean by four strokes? Okay. So how exactly the power will be generated, in which stroke the power is generated. Okay. So just I'll revise this thing and then we'll go with the engine management system. Okay. So this is representing four-stroke engine. We'll discuss the working of this four-stroke engine. Basically, yesterday we have gone through the components of these engines. Okay, so this is the crankshaft, and on this crankshaft, through the piston and connected rod, through the connected rod, the piston is connected to this crank. Okay, and this one is the camshaft, okay, which is rotating in synchronization with the crankshaft, okay, and which is controlling the opening of inlet and outlet valve. Okay, so as you have just gone through or as explained in that video, so in one cycle there are four strokes existing. Okay, so those four strokes are will be repeated continuously uh, for working of the engine, and those four strokes are known as intake, compression, power and exhaust. Okay, so in all these strokes your piston is moving from top dead center no, top dead center position to the bottom dead position. So there are two positions fixed in the cylinder and your piston is continuously moving between those two positions. Okay, so whenever we are talking about intake, it usually starts from the uh, top dead center. Okay, so which is at near the your spark plug or the inlet or outlet valve. Okay, so as the position moves down, the vacuum get created within the cylinder, and that vacuum is responsible to just draw the air fuel mixture into the cylinder. Okay, so fuel is injected into the intake port and is timed to coincide with the intake stroke. So this synchronization is done with the help of ECU. ECU will decide when to input the air, when to draw the air, when to mix fuel, how much air and fuel is to be mixed. Okay, and this air fuel mixture will be entered, will be just taken into the cylinder, and this will be done till your piston reaches to the bottom dead center. So whenever piston reaches to the bottom dead center, that is end of your intake stroke. And to move your piston from the top dead to the bottom dead center, this crankshaft is rotating through 180 degrees. Okay, it rotates through 180 degrees. So in the next stroke, again your piston starts moving up, towards upwards. Okay, so because of that, the compression of this air fuel mixture is taking place. Okay, and during that, again your crankshaft is rotating through further 180 degrees. Okay, so because of compression, a very high temperature has been created there. Okay, so has been generated within the cylinder, and whenever your piston reaches near just before the top dead center, your spark plug will be ignited. Okay, so that is known as your power stroke. Within the power stroke, as soon as your piston reaches to the top dead center, okay, spark plug will be ignited, and because of ignition of this spark plug, the combustion of air fuel mixture is taking place, and because of combustion, again the heat get generated, the pressure has been generated, which is responsible to push down the piston again, okay, back to the bottom dead position. And hence in the power stroke, again your piston is moving from top dead center to the bottom dead center. Okay, which is again responsible. So in first two stroke, the crankshaft has completed one complete rotation. So again it has started the second rotation. So again in power stroke, crankshaft will rotate through further 180 degrees. Okay, so this power stroke is the main stroke where the actual power which is used to drive your wheels will be generated. Okay, so out of these four stroke, the power stroke is the important stroke which is responsible to generate the required power for driving the vehicle. Okay, and once again when your complete combustion process has been completed, that means whenever piston reaches to the top dead center, bottom dead center, whatever is the gases which has been generated out of this combustion needs to be given out. So that is known as your exhaust stroke. Okay, in this exhaust stroke, the outlet valve will be open, and whatever are the gases generated because of the burning of this fuel and air mixture, those gases will be given out through this outlet valve. Okay, so this is known as exhaust. So like this, in one cycle, uh, two complete revolution of crankshaft is taking place. Okay, and there are four different stroke, out of which the power stroke is generating the required power for driving the vehicle. Okay, so this is how your SI engine works. So a CI engine is similar to the SI engine. Only the difference is this spark plug has been replaced by the fuel injectors. Okay, so as soon as and only air will be taken during the intake stroke inside the cylinder. So this in compression stroke, that air has been compressed, and the compression ratio will be 1/20th of the actual volume. Whatever is the air you have taken, the complete 1/20th of that actual volume is the compression ratio for the CI engine, whereas this compression ratio in case of SI engine will be 1/8 of the actual volume of your air fuel mixture. Okay, so here only air is taken inside the cylinder, that is compressed. Because of that compression, again air has been heated. Okay, and again as soon as your piston reaches nearer to the top dead center, the fuel, the vaporized fuel, the fuel has been passed through, it has been maintained at a particular temperature to ionize that fuel, and that ionized fuel will be entered as soon as your piston reaches to the top dead center. And when this highly ionized fuel or diesel will be added into this cylinder, so your air get burned, or it starts, the combustion will be started, it get ignited. Okay, and burning of that air fuel mixture is taking place in the compression stroke. And because of burning, again the whatever pressure has been generated, it is responsible to push your piston downwards, and that particular stroke is known as power stroke. Okay, and because of this combustion, the whatever is power generated, that will be utilized to drive the vehicle. Okay, so it works similar to the SI engine, only the difference is in CI engine, instead of spark plug, we are using fuel injectors. And there is the differences. In case of SI engine, we are taking in the air fuel mixture directly. Okay, and that fuel mixture will be ignited by generating spark using the spark plug. Whereas here only air will be taken in case of CI, that will be compressed, and as soon as at the end of compression stroke, we are just adding the ignited fuel in that, which is responsible for the combustion process, which is taking place in the power stroke. Okay, so that is the difference, and both SI and CI engines requires used in car are working on the 4-stroke engine. So this is how your engine works. Okay, so these are various models of the engines which are known as multi-cylinder engine. Okay, as we discussed, so all these are representing single engine in different strokes. Okay, so one particular cylinder is responsible to generate power only for 180 degrees. Okay, if we are considering the complete cycle consists of 360 degrees. That is two complete rotation of crankshaft. Okay, out of these 360 degrees, only the 180 degrees which is responsible for generating the actual power, and that particular single cylinder power generated is not sufficient to drive the vehicle, and hence instead of single cylinder, multi-cylinder engines are used in the vehicle. Okay, so these are representing different structures of the multi-cylinder engine. Okay, so where if all the cylinders are mounted in a single row, that is known as inline multi-cylinder engine. Whereas if the cylinders are mounted like in V shape, so those are known as V-line multi-cylinder engines. Okay, so multiple, depending on the structure, depending on how much power is to be generated, so the number of cylinders varies, as well as the structure may vary, okay, from vehicle to vehicle. Okay, so this is how if we are talking about 4-cylinder, so currently we'll just consider this inline four cylinder. So it has been just programmed such that out of these, sorry, 720, not 360, out of this 720 degrees, that is 2 rotations of crankshaft. Okay, for every cylinder will generate power during the different time duration. That is, for example, if we are saying during the first cycle, that is during 0 to 180 degree, your cylinder 1 is generating the power. Okay, whereas rest of the cylinders are in different strokes. Okay, whereas next 180 degree to 360, 180 to 360 degrees, your cylinder 2 is generating power. That means your cylinder 2 is working into the power stroke. Whereas in the for next 180 degrees, cylinder 4 is in the power stroke, and for the remaining 180 degrees, your cylinder 3 is generating the required power. So that means throughout the complete cycle, one of the cylinder is responsible to give the required power, which will be used to drive the vehicle. Okay, this is how the power generating capability of the engine can be increased. Okay, and hence the multi-cylinder engines are usually used so as to continuously generate and supply power to drive the vehicle. Okay, is that clear? Okay, so this is the firing order. So as I said, the multi-cylinder or the number of cylinders varies from engine to engine. So these are the configurations. Okay, there may exist 3-cylinder engine, 4-cylinder engines, 8-cylinder engines, 8-cylinder inline, 8-cylinder V type. Okay, so before using that engine or while designing the engine, the firing order has been decided. What do you mean by this firing order? Is the power stroke when the spark plug should ignite. Okay, which spark plug corresponding to which cylinder is to be ignited? That is nothing but your fire order. Okay, so that is defined as we have discussed here. It's not 1, 2, 3, 4, but it's 1, 2, 4 and then 3. That means first cylinder is in power stroke, then the second is going into the is generating the power, then fourth cylinder is generating the power, and then it's third cylinder. Okay, so that is representing your power stroke. It will be either 1342 or 1243 is the firing order in case of 4-cylinder inline. Okay, so this is, it can be 1432. Okay, similarly, the firing orders are decided, and in the same firing order, your timing signals will be synchronized, and accordingly, each spark plug will be given the spark signal. Okay, so this is how your engine works. Okay, so what is the difference between inline and V line? Is compared to inline 4-cylinder engines, the advantage of V line engines is that it requires it is compact and takes lesser space as compared to your inline engines. Okay, so it is short in length along the crankshaft and with 90-degree V angle, perfect primary balance, giving a smooth and nearly vibration-free operation can be obtained using V-line engines. Okay. The disadvantage of V-line is the synchronization of your inlet outlet wall or the construction of those just inlet outlet walls, camshaft and crankshaft synchronization that becomes little complex, okay, as compared to inline structure. Okay, so that is the disadvantage. So, and because of this compact structure and adjusting all the components within the lesser space, okay, so it becomes more expensive as compared to inline cylinders. Okay, so this is the comparison of your inline. This simply these slides are representing the animations, how the engine works. I think we have gone through the videos. I'll skip this animation. Okay. This is the comparison of petrol and diesel engines. Already we have done. So petrol engines are known as SI engines or gasoline engines, whereas diesel engines are known as compression engines. Okay. So as from name, it uses petrol as a fuel, diesel as a fuel. It is spark is used to ignite the fuel. The heat of compressed air ignites the fuel. As I said, the compression ratio is 1/20th, whereas here the compression ratio is 1/8 of the original value. Okay. Carburetors is used to supply the mixture of air and petrol vapors. Nowadays, carburetors are nothing but electronically controlled fuel injectors only. Okay. And here the fuel pump and injectors are used to spray the fuel in the compressed air. Okay. So petrol engines are light in weight as compared to diesel because diesel engines has to withstand with very high pressure and high temperature as compared to your petrol engines. Okay, and hence these are huge and stronger as compared to the petrol engines. The initial cost of the petrol engine is low as compared to diesel engine. Okay, but the running cost of petrol is more because the cost of petrol is more as compared to diesel. Okay, and hence running cost of diesel engine is cheaper as compared to the petrol engines. Okay, so usually the petrol engines are used for light duty application as like passenger cars. Okay, we are using this are suitable, petrol engines are suitable, whereas the heavy vehicles like truck and all those things requires your diesel engines. It cannot run that efficiently on your petrol engines. Okay, and hence the heavy duty applications, for heavy duty application diesel engines are used. Thermal efficiency is low as compared to diesel engines in case of SI engines. Okay, the engine speed and power is controlled by limiting the air entering into the engine in case of SI, whereas here the engine speed and power is controlled by controlling the fuel quantity. Okay, that is admitted to combustion chamber. Okay, so this is the difference between petrol engines and diesel engine. Okay, so usually petrol engines are preferred for the this passenger cars. Okay, the reason behind that is diesel engine they have higher compression ratio which tends to be heavier than the SI engines. Okay, diesel engines the initial cost is more as compared to petrol. Okay, so diesel engine because of the weight and compression ratio tend to have lower maximum RPM as compared to SI engines. Okay, the speed, the maximum limit on the speed is lower as compared to SI in case of diesel engines. Okay, diesel engines are high torque rather than high horsepower. Okay, and then tends to make diesel cars slow in terms of acceleration as compared to the SI engine or the petrol engines. Okay, the another disadvantage is it is responsible to produce smoke as compared to the petrol. And one more drawback we can say is it is harder to start in the cold weather. So your diesel engines needs to be continuously in use. It should be continuously in work. We cannot keep your engine off for the longer duration. Then it gives us the starting problem. Okay, so that is the problem with the diesel engines. And as it is heavier, okay, it results into more noisier and tend to more vibrate as compared to the petrol engine. Okay, so diesel fuel is less readily available than gasoline. So these are the limitations or what are the terms which are making the petrol engine more comfortable as compared to the diesel engine. Okay, what is the advantage of diesel engine? Only the advantages for longer life. Okay, it is giving you the fuel economy, and the engines, the life of these fuel engines are uh, longer as compared to the SI engines. Only these two are the terms which are responsible, are making the diesel engines more suitable as compared to the SI. Okay. So if we are considering the longer term economy, your diesel is giving you are resulting to save money, okay, in case of fuel and the engine life. Okay. So this is all about SI engine and CI engine. Okay. Any doubt in this? This.
Yes.
Okay. So that completes our SI working of the engine and comparison of SI and CI engine. Okay. Now we'll see what is the significance of air fuel ratio. What do we mean by air fuel ratio? Okay. So air and fuel ratio, as you know, for combustion we required the proper air and fuel ratio. Okay. So air fuel ratio can be defined as it is the mass ratio of air to fuel. So fuel can be in the form of solid, it can be in the form of liquid or gaseous. So CNG operated vehicles are nothing but the fuel used in that is gaseous. Okay. Whereas liquid, petrol, diesel are the liquid. So the mass ratio of air to fuel is represented, is known as used in the combustion process, is known as air fuel ratio. So the proper air fuel ratio determines whether a mixture is combustible at all or not. Okay, and how much energy is released and how much unwanted pollutants are produced in the combustion process. Okay, so that is determined from the air fuel ratio. If the exact enough air is provided to completely burn the fuel that has been added, okay, so that ratio is known as stoichiometric ratio. Okay, so this is the stoichiometric ratio. Air fuel ratio is nothing but it's the combination, or it's the ratio of air to fuel which is responsible for completely burning your air and fuel mixture. Okay, so that is known as stoichiometric ratio. The ratio which is less than that are known as rich mixtures, and the ratio which is greater than that are known as lean mixtures. Okay, so what do you mean by lean, or what is that stoichiometric ratio? For petrol and diesel, it is that ratio is 14.7:1. So what this ratio is representing, if we are taking 14 point, the air mass is 14.7, in that proportion your petrol mass should be added as 1%. Okay, so this is the ratio which is used for SI engine, and for CI engine it will be 20:1. Okay, and if this mixture is less than, this ratio is less than this, it is known as rich mixture, and the ratio greater than this is known as lean mixtures. Okay, so how it is responsible, actually the or what these terms exactly represent, or how we have achieved this 14.7:1. So that can be represented, I'll just show you the calculation. So this is what is considered as gas plus air, that is nothing but fuel plus air, and the corresponding masses, atomic masses are considered, and if we are trying to get the exact balanced equation, from this balanced equation, if we substitute the atomic weight for the corresponding this gas and S, or the oxygen, nitrogen, carbon and hydrogen, then we will get this ratio approximately as 14.7:1. I have given this as approximately 15.1. Okay, so this equation is representing the balanced equation, which is representing the the complete burning of this gas, which is resulting into carbon dioxide and water, okay, and nitrogen, which are harmless gases. Okay, so this is how your stoichiometric ratio has been defined, can be calculated. And how it is playing role is that depending on various conditions, the ratio will differ. This is one of the graph which is representing the compromise, or where we are trying to get the maximum power efficiency as well as fuel efficiency. Okay, so this is representing the percentage power as the air fuel ratio is changing, and this graph is representing the fuel efficiency graph. Okay, so and here you can just check it. This is representing your stoichiometric air fuel ratio. Okay, so 14.7. Actually, these 2 points should meet on this particular line. Okay, after this ratio, that is for lean mixtures, so we are trying to achieve maximum fuel efficiency. Okay, whereas for the reach mixture, that is below this 14.7, we are obtaining maximum power be generated. And to compromise these two things at stoichiometric ratio, we are trying to get maximum power as well as maximum efficiency. Okay, so but it's not possible that throughout your driving cycle to maintain the same stoichiometric ratio. Okay, so depending on various driving conditions, the need is changing. For example, here we have represented 3 different conditions. Okay, the regions which are divided into idling range, that is there is no load. In that case, it is changing from rich mixture to the lean mixture. Okay, whereas for cruising range, it uses the lean mixture, that is trying to uh, get the maximum fuel efficiency. Okay, and again for the high power range, that is whenever load on the engine is increasing, so it is going into, or it is using the rich mixture, where we need to supply more fuel. Okay, so what this rich and lean mixture is representing, rich in terms of rich mixture means it is less than 14.7:1. Okay, so that 14.7 is representing air ratio, and 1 is the proportional your fuel ratio. So when we are talking about rich mixtures, it is rich in terms of fuel. So more fuel will be utilized, will be used in case of rich mixture, whereas lean mixtures is the fuel proportion is less as compared to the rich or stoichiometric ratio. Okay, air fuel ratio. So that means depending on various driving conditions. Okay, so the the air fuel mixture is changing. The air fuel mixture used by engine is changed. Okay, so these are representing the same load or acceleration condition, cruise condition, cold starting. That is initial starting of your vehicle. Okay, and it can be explained well using this particular diagram. And this is representing the throttle opening. So how this throttle opening is controlling power, that also we'll discuss. Okay, and accordingly the combination of your throttle opening and air fuel mixture will be playing role to generate the required speed or required power. Okay, so there is also along with this stoichiometric ratio, there is one more term which is known as lambda. Okay, that is equivalence ratio. It is representing ratio of air fuel mixture to the ratio of air fuel mixture at stoichiometry. That means obviously at stoichiometric condition, this lambda value is 1. if it is greater than lambda is greater than 1, that is representing your lean mixture. And if lambda is less than 1, it is representing your rich mixture. Okay. So sometimes it the same air fuel mixture is also can be represented in terms of lambda. Okay, which is representing the same thing. Lambda equals to 1 is representing your stoichiometry condition for the air fuel mixture. Okay. So here one more graph is there, how your air fuel mixture is affecting on this torque. Okay, the performance is, we have considered here torque generated by the engine. Okay, so at constant speed, constant spark timing, this is represented as the torque behavior, and you can just observe that at this 14.7, okay, at stoichiometry we are getting the maximum torque. Okay, apart from those, there are few more curves it is represented. That is during combustion, what are the COs generated? The out after combustion, what are the gases generated? So you can observe at this particular level, the CO generated, the amount of CO generated is, whereas hydrocarbon is represented, it is reducing. So these graph we are getting the lesser amount of gases generated at stoichiometry, and this is representing your brake specific fuel consumption, and that also we are getting minimum at this particular point. Okay, and hence this air fuel ratio plays very important role to reduce the pollutants as well as to increase the performance of the. Okay, and hence through the electronic measuring instruments or through the electronic sector, we are trying to get, or we are trying to maintain required air fuel mixture whenever we are taking that or adding it to the cylinder. Okay, this is all about your air fuel ratio, how that air fuel ratio affects on the working, or it will be used to improve the performance of an engine and to reduce the pollutants. Reduction in the pollutants can be just explained from this graph, and how your maximum fuel efficiency, this efficiency is representing fuel because the amount of fuel added is less as compared to air. Okay, so it is giving us fuel economy or fuel efficiency, and this part is giving us maximum power. So wherever high load engine is working on high load, so obviously we need to provide the more fuel as compared to the low lesser load engine, okay, or in the cruise control, okay, cruise controlling side. That runs on the lean mixture. So this is how your air fuel mixture is affecting the working of engine. Okay, so this is representing electronic control, engine control, or it is also known as engine management system. Okay, so the various components, will just discuss these components in terms of engine management system and engine control, engine functioning, okay, and the control units. Okay, by now, whatever points we have discussed, I think we will come to know that the required power for driving your vehicle is generated by the engine, the power stroke. Okay, and second thing that we have concluded that this the maximum power can be generated by using the proper air and fuel mixture. Okay, so these two terms are responsible for generating the required power. Okay, and just to get the proper functioning of engine. That means now what exactly this engine management system is doing and how exactly all these controls are taking place. Okay, that can be explained by if we want to control the engine, that engine control is decided by the driver. Okay, so at what speed we have to drive our vehicle has been decided by the driver, and based on that decision we are controlling the engine. Okay, and that control is done by just pressing your accelerator pedal. Okay, so as you're pressing that accelerator pedal, according to the accelerator pedal your speed is changing. That means the engine power will be controlled. So how it will be controlled? So as soon as you press your accelerator pedal, that accelerator is directly linked to the throttle plate. What is this throttle plate? Is inside the intake manifold. Intake manifold is the uh, component where we are just taking your air and fuel and mixing that air and fuel, and that mixture will be supplied to the. Okay, it is simply the pipeline like a structure. Okay, and within that pipeline like structure your throttle plate will be mounted. So this is presenting the exact view of your throttle plate. Okay, so this is the cylinder or pipe you can just consider through which air is flowing, and within this is the throttle plate position is changing according to the accelerator that is pressed by the driver, or according to the power that we want to generate from the engine. Okay, so this accelerator pedal is directly linked to the plate. Okay, there either initially the mechanical linkages are existing, which is directly connecting your accelerator pedal to the throttle plate. Nowadays, we can say X by wire. That means directly sensor input can be connected, given to the controller, and through controller using those accelerator position, your controller is generating the signal which is required, which can be used to maintain the required angle for this throttle plate. Okay, so what this throttle plate is deciding, or how it is deciding how much air is to be taken based on how much pedal has been pressed in proportion to that acceleration pedal. Okay, so your angle for this throttle plate will be adjusted, and only that much air will be added to the intake manifold, and based on this volume entered for this airflow, for this intake air, the proportional fuel will be uh, just added into that intake manifold, and this uh, particular air fuel mixture will be passed to the cylinder. Okay, and this is how the fuel flow rate is determined based on the input air, and it will be given to the using fuel injectors. That much fuel will be taken in, and your air fuel mixture will be directed to the engine. Okay, an engine control system is an assembly of electronic and electromechanical components that continuously varies the fuel and spark setting. Apart from this uh, change in the air volume, fuel amount, so it is also controlling, engine is also controlling the spark settings, that is the timing at which the spark needs to be ignited. Okay, so three main features based on the accelerator control or the acceleration pedal, it will decide the angle of the throttle plate. So based on the angle throttle plate position, the amount of air will be taken inside that intake manifold. Using air monitoring system, the volume of the air will be measured, and in proportion to that, fuel metering system will enter the fuel. Okay, and once this has been done, that there is another control system which is known as the timing control. So that timing control will be activated, which will decide the spark settings. for corresponding cylinders. Okay, so this is the job of your engine management system. Okay, so this is representing another block diagram, or this is the block diagram that is representing engine functioning and control diagram. Okay, so is this clear, the working of engine management system? Yes, is there any doubt in this? Are you listening? Okay. So now we'll see the functioning, or exactly how all these things will be controlled or synchronized. Okay. So this is representing your ECU, engine control unit. Basically, initially in the older days, the separate ECUs will be used for fuel control, for spark control, and for the exhaust gas. Okay. Whereas nowadays everything has been controlled by a single ECU. Okay, to which various sensor inputs are provided, and based on those sensor inputs it is generating the control signals, and based on those control signals various systems will be controlled. Okay, so this part is known as intake manifold, okay, which is consisting of your throttle plate, mass airflow sensor, okay, fuel metering sensor, okay, and this particular portion is known as exhaust manifold, where we have mounted the exhaust gas oxygen sensor. Okay, this is emission control, just the outlet, the exhaust gas system. Okay, and this is representing your drive shaft, which is controlled through the engine. Okay, and this is representing your ignition control system, which is responsible to control the ignition timings, okay, spark timing, to ignite corresponding cylinder. Okay, and this is the centralized electronic control unit. Okay, and this is one more system which is known as, we'll just go through one by one. The fuel metering system is used to set the air fuel mixture flowing into the engine through the intake manifold depending on the mass airflow sensor. Okay, so based on how much air is flowing, this sensor is sending signal to the engine, and in response to this signal it is giving signal to the fuel metering control system. Okay, and based on that signal the amount of fuel will be decided and it will be mixed. Okay, the spark control determine when the air fuel mixture is ignited. So based on this signal, okay, again the signal which has been generated from the control unit, that signal is given to this ignition system, which will decide the timing for the ignitions. Okay, after it is compressed in the cylinder of the engine, the power is delivered to the drive shaft, and the gases that are resulting from the combustion will be given out from this exhaust system. Okay, so there is exhaust oxygen. How much oxygen has been obtained after the combustion process, that will be sensed, and again that is given as an input to this engine so as to improve your combustion process. Okay, and this is exhaust gas recirculation. Some of the gas will be reused, okay, will be again given back, will be added to the intake manifold through the exhaust gas recirculation. Okay, so in addition there is a subsystem that collects the evaporated fuel. That is, whenever fuel will be ionized, some of the fuel will be wasted. So that wasted fuel will be collected by this evap, that is evaporating fuel vapor system, and it will be just prevented from being vented to the atmosphere, and it will be again considered, which will be reused in our air fuel mixture. Okay, so that is evap. It is just like recirculating gases, again reusing the gases which has been generated after the combustion. Same way, whatever are the fuel, vaporized fuel that we are using, reusing that again in our mixing process. Okay, So that is known as evap. So this is how your control system or CUs used to control the engine management system. Okay. So what are the engine parameters? Various engine parameters are basically a parameter is the numerical value of some engine dimension that is fixed by the design. So design parameters such as engine size, compression ratio, and so forth, these are fixed already at the time of engine design. Okay. The parameters which are changing during the engine cycles or the engine is active is mass airflow, fuel flow rate, spark timing, power generated by the engine, and the intake manifold pressure. So these are continuously changing depending on the need of the speed and the power that we want to generate from the engine. So what are the uh, various controllers? As already we have discussed the working of engine control unit. Okay. Here it is specifically separated that complete system into the input controller and as a output controller. Okay. The same system has been represented. System has been represented in terms of input controller, and based on this input controller, what are the actions or the control signals which are generated by the output controller. Okay. So as an input controller, the inputs which are connected to this engine control unit are throttle plate position. Then based on this mass airflow rate, okay, mass airflow rate, engine temperature, that is coolant temperature, that is also one of the important input that is required for proper functioning of your engine. Okay. Next is engine speed and angular position of your engine, that is crankshaft. Angular position is of engine nothing but it's the position of your crankshaft and camshaft. Exhaust gas recirculation valve position. Okay, how much exhaust gases need to be recirculated, that is decided from particular signal. Okay, and exhaust gas oxygen concentration, that is, as I said, oxygen sensors are used which are representing the amount of oxygen that is existing into the exhaust gases. Okay, and that will be taken as an input to improve the performance of engine. Based on these signals, okay, the output control signals generated by output controller. Actually, output and input controller are the same in control unit. Okay, so it will generate fuel metering control. Okay, so it will decide the amount of fuel. It will decide the ignition timing, that is ignition control, dwell and timing, and the exhaust gas recirculation control, how much gas is circulated, and how much that fuel is to be again taken in use. Fuel tank evaporation, emission control. So these are the signals which are generated by output control. So this is how your engine management system is working, okay, to generate required power, and it uses various input signals and generates the output signals, control signals to generate required power and the ignition. Okay, this is all about your engine management system. So again, there are few parameters related to your engine power. Quickly, we'll go through these parameters, performance parameters. One is power. So power is measured. It is an engine's ability to perform this. Okay, power is nothing but it's an engine's ability to perform your work. Brake power. So what is difference between this power and brake power? The actual power generated by the engine, but the power which has given to the drive shaft is not same as the actual power generated into the power stroke. There will be some losses because of friction between your piston and cylinder, and because of various linkages between crankshaft and drive shaft. So all these friction losses or inertial losses are subtracted from the actual power, and whatever resulting power that we are getting, that is known as brake power. Okay. So brake power is represented in terms of PB, whereas your actual power is known as indicated power, that is represented as PI. Okay. So this power, actually brake power, is measured using the instrument known as dynamometer, which is connected at the drive shaft. So using this particular instrument, we change various settings, like we can change the load and speed of engine, and then check for various different values of this load and speed, how your engine gives, or what is the power generated by engine. Okay. So apart from that, there is one more term which is known as brake specific fuel consumption. Okay. So it is simply ratio of fuel flow rate to the brake power output. Okay. So it is measurement of engine's fuel economy, how much engine will be, how much fuel will be utilized for various speed and load values. Okay. So torque, it's the angular force of engine's crankshaft with the cylinder pressure pushing on the piston. So basically, it's the force which is responsible to rotate your crankshaft. Okay. So that is known as your torque. Volumetric efficiency, the variation in torque with RPM is strongly influenced by the volumetric efficiency, which is described how well the engine function as an air pump drawing air and fuel to various cylinders. Okay. So it is representing basically variation in torque and speed, okay, based on your air and fuel ratio. Okay. Thermal efficiency, it is expressed as the mechanical energy that is delivered to the vehicle. That is the combustion power. It is the conversion of heat energy into mechanical energy, that is representing basically thermal efficiency. The heat energy is getting produced into the combustion process, which is responsible convert that heat energy into mechanical energy with the help of piston force that is applied on the crankshaft. That crankshaft is responsible to generate the mechanical. Okay. So this efficiency is, it is an expression. It expresses the mechanical energy that is basically drive shaft. Calibration, maintaining the required air fuel ratio, and this is done through the engine mapping. Engine map will discuss afterwards in detail. Okay. So it is simply the lookup tables which is maintained within your ECU for different speed and load conditions. Okay. So these are the various performance parameters which are used, which are related to your engine. So this completes our engine management, how engine works, what are the different parameters. Okay. I think should not be a problem. If you are having any doubts, we'll discuss those in next lecture. Next lecture, we will discuss our ignition system and fuel system. Okay. For today, we'll stop here. If you're having any doubts, you can ask.
Ma'am, no doubt.
Okay, okay then. Okay, see you in next lecture with ignition control system and fuel control system.
Okay.
Okay.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Good.